Hi guys, welcome to your first math class. I know this is probably a lot different than you expected, even in a remote setting. So I thank you for your patience and your understanding as I take some time. Um, Please use this video to not only learn today's material, but also get some um, foreshadowing and some expectations of how math class will look like and, you know, a little bit of about me. Okay, so each day we'll start off with a do now slide as I take attendance. Today's is pretty simple. You're going to take some notes today. So having a pencil handy and a notebook will be very handy. That's the do now. After we do the do now, we'll talk about the objectives of today, the goals, and then kind of our process for today or our itinerary. And I also like to include down here the title of each lesson. So today's lesson is 2-5, comparing proportional relationships. Our goal for today is students will be able to analyze equations, linear graphs, and tables to find the unit rates and compare proportional relationships. And so we're going to do a do now. We'll talk about a Sam and Bobby problem where we compare tables and graphs. We'll compare some pizza shops with equations and graphs. And we'll also talk about saving some money into an account through word description and graphs. And each one will see two different things where we're asked to kind of compare which one has a greater rate or a lesser rate. All right, so you see some representations up here. Table, graph, equations, graphs, and then the word descriptions is just like a sentence, but also to a graph. All right, so what is proportional relationships? You may remember this from 7th grade. A proportional relationship is defined by a straight line which goes through the origin, 0, 0. And I like to think of proportional relationships like this table. You can see the arrow pointing there. And it starts at 0, 0, and then the x is 1, the y is 3, the x is 2, the y is 6, the x is 3, the y is 9, so on and so forth. And you might notice a little bit of a pattern as I was reading that. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. So you notice a relationship in proportional relationships, which is you can multiply something to x to get y. And the reason why we start off with proportional relationships, which you saw in 7th grade, is because in 8th grade next week, we're going to talk about not in proportional relationships. And so if you see here in this table, it doesn't start at 0, 0. And even if I try to pattern like 1 times 4 is 4, 2 times 4 is, wait, it's not 7. And 3 times 4 is not 10. And 4 times 4 is not 11. So that rule's sort of not working like it did here, which makes this not proportional. And here's just a couple other diagrams of what proportional graphs look like, what proportional equations look like. You might remember this fancy terminology, a constant of proportionality. And we'll also call that unit rate or slope this year. So just some things to keep in mind. The standard that we're asked to work on today is 8EE5. And the big part that we're going to do is the second sentence here today. The first part we're going to do at a later date. Today we compare two different proportional relationships represented in different ways. So tables, graphs, equations, tables, equations, graphs. And that's what we're going to dig into. Okay. So as I go through math class, we're going to have the problems on our left here. This is the account that I'm having you work on while I'm gone is Savas Realize. We're going to use it a lot this year. So get familiar to the look of it. You can go back and next over here, you can see how many parts are remaining of the question, so on and so forth. I have a good rule that says if I'm writing it down, it's probably worth you writing it down in your notebook. So you notice this is a way I start my notes is my name, the date, the title number. So remember, this is 2-5, comparing proportional relationships. And then I like to write the goal. And you might remember this goal. This is the one I read, right here. And there's our 2-5. So all of this information you can find from the slideshow. Okay. So now that we know the goal, we know what we're about to do, copy notes, and think through the problems as I do. Let's get into the 5 questions. This first one says, Sam and Bobby want to know who cycled faster. The table shows the total miles Sam traveled over time, and the graph shows the same relationship for Bobby. So these are 2 bicyclists who have been biking for an extended amount of time. Maybe they're doing some sort of race across the state, or marathon, or a triathlon. Who really knows? And the question we're going to be asked to solve is, who cycled faster? Okay. So in order to do this, what we're going to need to remember is how to find the unit rate, and which we call the constant of proportionality for Sam. Okay. So I'm going to write, they give us a little bit of a setup here for Sam. 20 miles is the distance, 2 hours is the time, and it looks like they're getting that right from here. So here's a step you might remember from Mr. DeFranzo and Miss Ferranti from last year. They would create a proportion. So let's do 20 miles. We'll do a little line here. This is for Sam. Keep myself organized. 20 miles for 2 hours. And we want to calculate the unit rate. So let me go back a step. A unit rate is the rate. So a rate is a comparison of 2 things, just like this. The rate for 1 unit of a given quantity is called the unit rate. So if I told you I drove to Maine the other day and I drove 130 miles in 2 hours, you would calculate the unit rate as each hour, 1 hour, that's what makes it a unit rate, that 1 on the bottom, I would go 65 miles. So each hour I would go 65 miles, unit rate, because there's a 1 on bottom. So when I'm trying to apply that here for Sam, I'm going to say we need a 1 here, 1 hour. And hopefully this is drawing visions of Miss Ferranti or Mr. DeFranzo. You would say, well, how do I get from 2 to 1? One way is thinking of this from this to this as dividing by 2. And you guys remember the golden rule of math. Whatever you do to this, the bottom, we also got to do to the top. So let's see, 20 divided by 2 is going to be 10 miles. So now we know Sam's unit rate is 10 miles per hour. Okay, and you may have a really good question. Well, what if I didn't pick this first column, 2 hours, 20 minutes? Would it have worked for, like, let's say the last one, or this one, 4 and 40? So we can just quickly show you here. If I chose 50 miles, the last column, over 5 hours, we'd still need to calculate the unit rate. And so I'd put 1 hour. And now instead of dividing by 2, it looks like we got to divide by 5. Same thing up here. Divide by 5. 50 divided by 5 is going to be 10 miles. Right? So I would end up with the same answer no matter which row I chose. And that's because this relationship is proportional. Make that a little bit clearer. There we go. All right, so now we know Sam's unit rate, so we can lock that answer in, 10 miles per hour. We can check it out. We got some nice work. Look at us. We're doing great. I'm going to get rid of the table for right now because I think next comes Bobby. Let's do a little space here. I also like to do this as number one. All right, let's talk about Bobby. So Bobby is a bicyclist as well. We're going to, again, find the unit rate for Bobby, which is known as the constant of proportionality. And Bobby's represented by this graph here. And if you look at the next part, it's kind of guiding us as where we should look. So remember, this is a coordinate point, x comma y. The first number corresponds to x, the x-axis right here. The second number, which is we have to fill in, is the y coordinate, which is the y-axis right here. So I'm going to look for 2 hours. It looks like Bobby biked 16 miles. 16 miles. And they want us to also look at 4 hours, since 4 comes first. 4, it looks like Bobby went 32 miles. Okay, let's check that out. Boom, nice work. Crushing it. So now we have to figure out the unit rate again, that constant of proportionality. How many miles per 1 hour? So again, we have our choice here. We can use 2 hours, 16 miles, or we can choose 4 hours, 32 miles. I guess we'll use the second one. Do some tough math here. 32 miles, 4 hours. Not a unit rate because the denominator is not equal to 1. So let's make a unit rate. Let's put a 1 down there. 1 hour. Tells us what to divide by. In this case, divide by 4. Divide by 4. 32 divided by 4. Please feel free to use a calculator if you're having trouble with your multiplication facts, your division facts. I'm not testing you on that. I'm testing you on 8th grade stuff. So use your tools wisely. So 32 divided by 4 is 8 miles. 8 miles per hour for Bobby. Let's fill that in. 8 miles per hour. We check it. We did good. All right. So big part of today, finding the unit rate. We just did it for a table for Sam, a graph for Bobby. And now we just got to do the easy part. We got to compare those rates, compare those unit rates. So let's see. So did they both cycle at the same speed? Did Bobby cycle faster or did Sam cycle faster? So I'm looking. We got Sam up top, 10 miles per hour. Bobby, 8 miles per hour. Pretty obvious, 10 is greater than 8, so Sam cycled faster. Let's check it out. We got it. All right, we are moving on, ladies and gentlemen. So take some time, pause the video, or go back if you need to for any steps. And we're going to go on to the next one. Do a nice little line under here. All right, our second problem involves, realize must know I'm a pizza fan. We are going to talk about 2 pizzeria shops. Looks like there's Pizzeria L and Pizzeria W. Aren't those great names for pizza shops? Man, I had the greatest pizza at Pizzeria W the other night. Cheese, pepperoni. My goodness, it was great. Just kidding. All right. So let's read the problem and we'll compare it and find some unit rates. The amount of money, Y, so money being the Y-axis here, the amount of money Y, Pizzeria L, the first store, makes by selling X pizzas can be modeled by the equation Y equals 19X. The relationship of the amount of money Pizzeria W is shown in the following graph. Which pizzeria makes more money per pizza? So again, we're comparing which pizza shop is making more dinero, more money. All right. So let's start with the graph because we've already done a graph. We're feeling good about it. Pizzeria W is the graph. The only difference between this one and number one is they don't tell us where to look, right? The last one told us look at the 2, look at the 4. So we are going to look at the x-axis just like last time, but it doesn't really matter what number you pick. And you can try this on your own. You can pick something different than I would, but we should end up with the same unit rate. So I'm going to pick 9. I'm going to pick the middle of 8 and 10 here. This is 9 pizzas, and I'm going to go all the way up the graph, and I'm going to say, oh, it's right in the middle there. Maybe I don't want to do that calculating, right? Maybe I pick a smarter choice. Maybe I pick 6 because 6 is my favorite number. So for 6 pizzas sold, let's see, that's a little bit easier. 6 pizzas, $84. So 6 pizzas, $84. And a really good question you might have as I'm writing this is, how did Mr. G know to put dollars above pizzas? I know Ms. Ferranti makes a really good point, an emphasis on this, and I'm sure Mr. DeFranzo does too. When we calculate rates in math, we always put the y variable over the x, y over x. So if you look on my graph over here, the y is the money, so money goes on top. X is over here on the bottom, and that's the pizzas. So I knew to put pizzas on the bottom. Okay. Not a unit rate because there's not a 1 in the bottom, so let's put 1 there, and let's calculate it. How do we get from 6 pizzas to 1 pizza? We divide by 6. We do what we do to the bottom, we do to the top, ladies and gentlemen. 84 divided by 6 is, that's stumping me for a second. I've had a long day, so let me model. Ready? If I didn't know, hey Siri. She's not listening to me. Hey Siri. What is 84 divided by 6?
84 divided by 6 is 14.
All right, thank you, Siri. $14. Use your tools appropriate, ladies and gentlemen. So Pizzeria W is charging $14 for each pizza. All right, so let's see. The other pizzeria that we have to compare that to is Pizzeria L. And it says it makes X pizzas can be modeled by the equation y equals 19x. And I was telling my other classes that equations are always I feel the most difficult for students. You know, they really understand tables, they really understand graphs, but equations stumps them sometimes. So let's do a little strategy I like to call make a table. So we're doing Pizzeria, oops, spelling it wrong. They might come after me now that I'm spelling it wrong. Pizzeria L has the equation y equals 19x, okay? And when I see equations, I like to make a table. So here, I'm gonna draw a nice little vertical line like this. I'm gonna make an empty table. X always comes first, y second. And when I have an empty table, I get to pick the numbers for X. So maybe I'm having a few friends over and I'm thinking, I gotta order 2 pizzas. I'm telling myself in the equation, I see X is right here. We're calling X 2. In this example, you can pick any number. I'm picking 2. And I'm gonna plug it into that equation just like it is. The only substitution I'm making is where I see the X, I'm gonna plug in 2 right here. And then we're gonna do some math. y equals 19 times multiplied by 2. That would be 38. So according to the equation, 2 pizzas cost $38. And I could keep going. I could try it for 4 pizzas or 5 pizzas, but no matter what I pick, because this is a proportional relationship, the unit rate will always be the same. So let's calculate it. $38, 2 pizzas, not a unit rate because there's not a 1 on the bottom. So let's make it. Divide by 2, divide by 2, and 38 divided by 2 gives us back our $19, which you may recognize in the equation. But that is our unit rate of Pizzeria L. And I'd challenge you guys or ask you guys to, think of another number, calculate it, and see if the unit rate comes out to be the same, or am I a liar? All right. But we have 2 pizzeria shops. We have 2 unit rates. It is time to compare. Let's look at the options we have to compare right here. A, Pizzeria L makes more money per pizza. Whoops. They make the same amount of pizza. B, or C, Pizzeria W makes more money per pizza. So I'm going to look. Pizzeria L makes $19 each pizza. Pizzeria W, $14 per pizza. It would appear that Pizzeria L is the more expensive pizza. They're making $19 as opposed to $14. So I'm going to pick A and lock it in. Excelente. We got it. Okay. So take some time. I'm going to set up for the next question. Copy any notes you need to. Pause the video. And we're going to move on to the third and final problem of the day. Let me give myself a new page here. And let's get the new problem. This is number 3. And we see 2 people. Looks like Lana is one person here. I recognize a name. And then Elania. Very similar names. But we have Elania's account. And the graph shows the amount of savings over time in Elania's account. Right here. And then a different person, Lana, meanwhile, she puts $40 each week into her savings account. If they both begin at 0, who is saving at the greater rate? So who's saving more money? All right. Again, we know graphs pretty well now, so let's start with the graph. Elania. She's in the graph. Okay, so I'm noticing, let's see. What's a good number here? Let's try for 2. Let's keep the numbers small this time, All right, so for 2 weeks, it looks like, according to this blue line graph, for 2 weeks, Elania is saving $74. $74. Okay. All right, so you're going to make your fraction, your rate. And one other key information you might remember from 7th grade, maybe I'm confused again, I don't remember the y goes over x. Another key hint is anything involving time belongs on the bottom of your fraction or the denominator. So because there's time in weeks here, we're going to pick that 2, and we're going to throw that down the bottom, 2 weeks. Up top would be the $74 that she saved. Calculate the unit rate, divide by, well, let's write the 1 first, Mr. Gallucci. God, going too fast. 1 week. So again, we're going to divide by 2. Do the same to the top. Divide by 2. And 74 divided by 2 should give us, I'll check my mental math today. It sounds like $37. So Elania is saving $37 each week, or every 1 week. And then we have Lana. And Lana's is the word description. In the word description, it tells us Lana, meanwhile, puts $40 each week. And you saw me leave this highlighted. That's purposeful. I'm going to make my rate. The number they only give us is $40. So remember, money went on top here. So let's keep that the same, $40. And then we need the time in the bottom. So you got to kind of be careful, readers, and look out for these keywords. Each, per, not like the purr from a cat, but per, P-E-R. And also another keyword that they'll use a lot is every. $40 each week, $40 per week, $40 every week. Notice how the week is singular, meaning 1 week each week. So the number we're going to put down the bottom is actually 1. And I'll ask a question to the blank class. Is this a unit rate? Yeah, it is, because there's a 1 on the bottom. Look at that. That one was easy. Already done for us. We just had to read between the lines. And all right, so we got Elania saving $37. We got Lana saving $40. Ladies and gentlemen, it is time to compare those rates. So we got 2 choices. Lana saves at a greater rate, or Elania saves at a greater rate. I'm looking over here and I'm seeing 40 is bigger than 37. Pick the right one, Mr. G. 40 is greater than 37, so Lana is saving at the greater rate because her unit rate of 40 per week, $40 per week, is greater than Elania's unit rate of $37 per week. We check it out. We got the good job. We got the green check mark. We are good to go. So I always like to go back in time here. And I like to ask my students at this point, do you think we've done it? Let's see. Analyze equations. Remember the pizza shop? We looked at that pizza shop equation. We looked at linear graphs, I believe, in every problem. We saw it in Elania's graph. We saw it as a pizza graph. We saw it as Bobby's graph. And we also saw a table in the first one with Sam to find the unit rates. I think you guys are all pros there now. And we compared proportional relationships. We said, which one's greater after we have those? So this has been a tremendously successful lesson. I can see the smiles in your faces. Look at, you see the light blinking? That's me watching you. Just kidding. I hope this made sense. And what I'm going to leave or end this lesson with is your asynchronous work. So by the time this video ends, there should be 2 assignments in your Google Classroom. 2-5, Math Excel for School. It looks a lot like this assignment. So you're going to go through those same processes. And then there's also a lesson quiz. I really recommend doing this one first because you can always use the question help button to help you solve a problem, to view an example, to watch a video, and then when you're done with that, there's a 5-question mini quiz in there, but you won't have that question help button. So you won't have any opportunities to ask to get some help. So do the best you can on your own there, and that helps me figure out what else I can need to teach. Again, thank you guys so much. I know this is not the easiest to learn on your own through videos, but I promise I You will do great. Stick with it, and I will see you very soon.